So in C2, we're going to do a kinematic problem. Let's say kinematics. We're going to do a Camaro. Now, in the previous chapter, we talked about a Camaro stock car going from 0 velocity to 300 kilometers per hour in 40 seconds. So what I would like to do here is find the average acceleration in terms of g, and then the distance traveled, and then c, the time to go 1/2 the distance. And we're going to assume constant acceleration so we can use our formulas. All right, so to do the average acceleration, we use v is v naught plus at. We know that this is 300 kilometers per hour. We know that this is 0, starts from 0. And we know that the time is equal to 40 seconds. So we can solve for A is simply V over T, where V is your 300 divided by your 40 seconds. It's good to keep the units here. Kilometer per hour, 40 seconds. And when you divide this out, you get 430, which is 7.5 kilometers per hour per second. Now, if we want this in terms of g, we're going to convert, where we're going to want to put the g and the value, but see, now I don't know the value for g with hours. That's a little confusing. So I need to convert. So what I'm going to do first here, shift gears and go with my conversion. In fact, we could do it here. What we're going to do is we're going to take the kilometers and replace it with 1,000 meters, per kilometer. And that's going to get rid of the kilometers, but then I got the hours to deal with. So let's go ahead and we want to cancel the hour. And if we do that, we need 3,600 seconds. So the hours will cancel, the kilometers will cancel. And what we get when we do that, we get 2.08 meters per second squared. Now I can find out in terms of g, because I know 1g is 9.8 meters per second squared. So when I divide the 9.8 into the 2, it's like 10, so it's going to be 0.2, so 0.21 g. So that's the first one then. So then B, we want the distance traveled, and what we do there is, since we know the initial and the final, and we know the acceleration, I like this formula, the 2AD formula, is v squared minus v naught squared. So this one here is going to be 0. This one here is going to be the 300 kilometers per hour, and then you have to square it, but that's what the v is. And we know what the a is. The a is right up there. But now I need to work with the meters per second. I want to work with meters per second. This is my preference. So we need to convert. So if we convert this, we have the same thing again, the 1,000 meters per kilometer, and then we have the 1 hour for the 3,600 seconds. So the kilometers cancel, you get meters, and then the hours cancel, you get seconds. And when you do that, you get 83.33 meters per second. Notice I keep more significant figures, because I'm going to round off. I'm going to round off at the end. So I don't want to round off my answer away with all these steps. So that's what we're going to do, keep those. And we use this formula now where, see, the D here is going to be the V squared over the 2A. So that's going to be 83.33 squared over 2 times 2.08. And when you work that out, you get 1669 meters, which is 1.67 kilometers. So we got the second one. And then for the third thing, the time to cover half the distance, well, since I have distance and the acceleration, and here's where you can often, use different approaches, different equations, and play around. In physics, there's more than one way to do things, but I'm going to use this formula where I'm going to plug in for the distance, 1/2 this. So this 1/2 this value is going to be 834.5 meters, because you want the distance now to be the 1/2 distance. So in physics problems, distance becomes different things for different problems. So now the distance is now different because I have a different problem. And if you want, you could put a little 1/2 subscript there, but I think the context is okay. I'll just write down, this is the half distance. All right, so if we do that, remember that the velocity that we started with is 0. So here I'm going to have the 1/2, and then I'm going to have the 2.08 t squared. This is easy to work out. We're going to multiply by 2. We're going to divide. And to keep the units here, this is meters per second squared. And then when we do that, we're going to get T is 28.3 seconds. It's not a bad idea to actually do the steps with the units, where you have the 834.5, you have the meters, then you divide and put the 2.08 meters per second squared here, because then you see the meters are going to cancel and the second square is going to pop up. And then when you take your square root here, because the t is squared, you're going to get this value. So notice that the total trip was 40 seconds. So this corresponds to about 70% of the journey. In other words, 70% to go half the distance, and then only 30%, to go the other half.